In this lecture, we're going to talk about research questions. Research questions are what we need to get a good handle on before we can even start talking about statistics, the methods we use, and how we use them. So in this lecture, we're going to learn about the relationship between research questions, designs, and statistical analysis, or at least we're going to learn the research part of it. And then we're going to eventually use this in order to talk about how to interpret and explain research designs and statistics as they're reported in public health and other related health journals. So you've probably all heard this before in one form or another, starting in grade school, high school, college. The scientific process involves a certain cycle. A.D. de Groot, who was a chess master, actually put it in this context. The empirical cycle is such. You start with an observation. You say, hey, it looks like this is going on. And then you move on to induction. You make some conclusions about those observations. And then you move to deduction, and you say, well, suppose if this happens, then I think this will happen. And at that point, you can move to testing. And then once you've set up an experiment, you've collected some data, you can evaluate whether your hypothesis was correct, and then you might revise your hypothesis, and then we're back to observation. So that's the basic empirical cycle. Here it is in words. So our observation is a collection or organization of empirical facts. From that observation, we make some sort of induction where we would formulate a research question where we're saying, hey, I think this is happening. What would happen if? In the deduction, we then talk about creating testable predictions. So we're going to make that research question more specific. So we might say, for example, if, let's say, if the light turns green, then the cars are going to start to move forward. Whereas the research question might be just, the lights control how the cars move. So our deduction is a more specific prediction related to the research question. And then we would do our testing. So we would come up with a study design. And the study design may vary depending on your field, the research question asked, how feasible it is to collect some of the data, as well as ethical considerations. In some cases, it might be okay to play with the stoplight and have cars stop or start at weird intervals. In other cases, it may create unsafe conditions, so I wouldn't want to do that. And those would be the ethical conditions. Once I've created the study design, then I'm going to collect my data, and I'm going to summarize it using either qualitative or quantitative methods. And then finally, I'm going to look at my results and I'm going to interpret them. So I'm going to take it one step further and say, okay, what can I say about my research question? I said yes or no maybe to the hypothesis, but what can I say more broadly about my research question? And then do I need to revise it and conduct another study? As we move forward in statistics, as we talk about research questions, as we talk about hypotheses, it's going to be useful to nail down some specific terminology. And we'll use this terminology throughout our course. So first of all, we can talk about the population. Generally in statistics, you may hear this referred to as the target population, and this would be the group of persons or items or years or whatever you're studying about which you want to make conclusions. So in the stoplight example, I may be making conclusions about the cars. So or the drivers in the cars more specifically, and that would be drivers of cars would be my population. The observation, sometimes also referred to as the unit of measurement, is the item, person, or time period on which I take measurements. So in the stoplight example, the observation might be the time when the stoplight turns green. Or I could classify it as a person in a car. So I could, at each green light, I can observe a person in the car and observe how long it takes them to start moving after the light turns green. Multiple observations are going to make up your data set, and often our data are arranged in spreadsheets where your observation is a row in the spreadsheet, and then I may measure multiple items on each observation. So for example, for the person in the car, the person may be my observation, and then my variables that I measure may include their age, their gender. It also may include what type of car they're driving. And then the response variable or the independent variable might be, for example, the time it takes them to start moving after the light turns green. And then our variables, which I've already started to mention, can be divided into two categories. The first category is our explanatory or independent variables. So those would be, if I'm doing a randomized clinical trial where I'm looking at new medications, the treatment might be my explanatory or independent variable. The explanatory or independent variable could also be a characteristic. So, for example, I might hypothesize, let's say that women start more quickly when the light turns green. In that case, the gender would be my explanatory variable. The explanatory variable is often referred to in a number of different ways. It could be referred to as the explanatory variable, it could be referred to as the independent variable, or it's sometimes also referred to as the predictor. And then sometimes in the case of a experimental study, it may just be referred to as the treatment. The outcome that you're measuring, or the response, is the second type of variable that we'll talk about, and that can be referred to as an outcome variable, a response, or a dependent variable. And this is typically your response of primary interest. So in the example that we've kind of made up here, the response variable is the time until the car starts moving after the light turns green.